Okay, well, we'll just do the green, dark green. Okay, so it says that the crosswalk's 10 feet wide, and the camera shutter is open for 1/40th of a second. And this is the image we have. Okay? We get this image. So we want to kind of, one of the goals is to figure out to estimate the speed of the vehicle as it's going through the crosswalk. Okay, so that involves lots of things. It involves understanding shutter speed. It involves relative size and understanding of speed. Okay, so we're going to put all that together. So how far did the SUV move while the shutter was open? Okay, so I'm going to use my eraser to draw on this. So it's really thick, but it does the job. Okay, so this is so what I kind of told you was we need to find a reference point on the vehicle where we can really tell where the start of the vehicle was and where the end was. And if you look, there's a really good one here is a white mark on the light. Do you see this? Yeah, so I'm going to draw it like right below it. And so like right there, that distance right there shows the length of the blur. And therefore, the distance the car traveled while the shutter was open. Okay, so how are we going to make sense of that? Well, how can we figure out what distance that is in the real world, right? So you might measure it on your piece of paper as some number of centimeters or inches or something, but how far is that in the real world? Yeah. Yeah, so it said that the crosswalk's 10 feet wide, so where are we going to look? So it's on your photo, there's all these different distances of 10 feet. So which one? So do I want from here to here? Do I want to make that 10? No, what about in the back, from there to there? No, so where? Yeah, where the shadow is, or yeah, someone said coplanar with the truck, that's a good way to put it. So right there is our 10. And so the question is, what is this? And so what is forming here? What does that look like? Bar diagram, right? Bar diagram. We've got 10. And this we know is 10 feet in the real world. So I'm not quite sure what the measurements are. But was that? Do you remember how many centimeters? What was the blur? You got 1.5 centimeters? Great. And you got 9 centimeters? Okay, so this is, you can do scaling or relative size. If you want to do scaling, what are you doing? You're taking scaling from 9 centimeters up to 10 feet. So what's your scale? Your scale is what number you multiply 9 by to get 10? What number do you multiply 9 by to get 10? Make it easy on yourself. 9/10, right? So we're scaling 9 centimeters up to 10 feet. So we want to also scale 1.5 centimeters by 10/9. And that will be the number of feet that it moves. So what's 1.5 times 10/9? Was it? 15/9. And let's get what is that? 1.67 feet. So did you get something similar to something in that ballpark? It's all estimation. So if it's like somewhere between 1.5 and 1.8, you did pretty well.
I got 2 feet.
2 feet?
Yeah.
Oh, so okay, so some of you were higher than this.
Yes.
Okay, so that's probably reasonable as well. Maybe ours is a little low. Okay, so maybe something around 1.8 is the best. 1.8 or 2. Okay. Questions on that? All right, so that was the idea of that. So now we want to, we'll call it 2. And we're going to make a bar diagram again, right? Now, different bar diagram. Now, this is our bar diagram to analyze speed. So what could the top bar represent?
Total distance.
Total distance, which was? 10 feet, crosswalk? No, what is it? I'm going to call it 1.9, all right? How about that? So 1.9 feet. And what's this? This is the distance traveled by the car. And the time the shutter was open? Was 1/40th of a second. What do you think of my bar diagram? Good start? No. Why? How should I change it?
You want to change it to, you want to add a whole second.
Yeah, because now I need to either draw 40 of these or extend this 40 times, which is, over here in the first row. Okay, so rather, instead, we want this to be what? 1 whole second. And then what's the length of this? Okay, so unknown, right? So we've done this before. So this is our unknown. It's the distance traveled in 1 second. What do we know? The distance traveled in 1/40th. Okay, so that's 1/40th of a second. So 1 second is 1/40th of a second. So the distance traveled in 1 second is 40. This is our, 1.9 feet? 1.9 feet, which is multiplication. And what do we get? Is that 78? 78 feet. What does that have to do with speed? Yeah, so 78 corresponds to, it's the distance traveled in 1 second. So therefore that's the speed, 78 feet per second. And if we wanted to, we could, because we all think in miles per hour and know what that feels like, we could do times 3,600 divided by 5,280. Is it the other way around? Do I have that right?
Yeah,
I'm going fast.
53.2.
53.2?
Yeah.
I was going to say, although some of these, I don't know what street that was, but some of our surface streets, have a speed limit of 45. So, do the sirens go or not? 8 over?
No, I thought it's 12 over.
He knows. Okay, so yeah, that was probably speeding through that intersection, but that feels reasonable. It feels reasonable, right? And that's also maybe our 1.9 feet was an overestimation based on because we were just
That made me question the whole time I was doing homework. So it's a residential area,
right.
Not possibly.
Exactly.
Okay, but it's enough ballpark that you can continue. If you got 80 miles per hour, then you know for sure something's
Well,
wrong.
even 50 though seemed like it was like I'm doing something wrong. There's no way that's going to be 50. And then I started thinking,
Okay.
well, maybe.
And it said that it stopped at a stoplight before, so you wouldn't split up that fast to the next.
Well, that was just a scenario. I don't know if that car stopped.
So I was just overanalyzing.
No, it's great. No, this is a really good discussion. You should think about your answers. It's much better to overthink an answer than to just calculate a number and move on without thinking about it. So that's very important. I think that's great that you did that. Okay, but yeah, 53. Thinking to yourself, okay, maybe I overestimated. Maybe it's more like 45 or 40 or something. But I'm in the ballpark, so it's okay. I can go on. Now, right? If you got 100 or 130, then you did something wrong. You did something wrong. Okay, questions on page 1. Yes, sir.
So margin of error, how much further up from that?
If your process is correct, that's the important thing. If you're thinking, you're understanding, your process is correct.
When I was doing it, I first calculated it out to 2 feet, but I had to save it. I was like, there's no way he would be going this fast. So I kind of went back and reevaluated it, and I got 1 point something feet.
So did you find that it was kind of a misestimation on your part, the 2 feet? Or
I just thought that I just kind of, it felt like
Yeah.
it was.
No, that's really good. That's great that you're thinking about what the answer means and going back and checking. That's excellent. But this is more about the process. Do you understand the process? There's estimation involved, so we're going to get different answers. As long as it's in the ballpark, that's fine. And 53.2 would be in the ballpark. Other questions? Okay, so then page 2. So I tried to encourage you to really understand the situation. So way out to the right, and so dx is the distance in feet from the street light, x seconds after passing it. So for this SUV, the value of x was 38.2 seconds at the moment the camera shutter was open. So 38 seconds ago, from when this picture was taken, it passed a street light. We don't know what speed it passed the street light, but that was that. So what does d of 10 represent? What does d of 10 represent? So what is our output? Our output is distance in feet from the street light. So this will be the distance in feet from the street light. Distance in feet from the street light at 10 seconds after passing the street light. Where's the truck at this point compared to the picture? So if you're looking at the picture, where's the truck? Way still to the right, coming towards the intersection, right? What's that? And in 28 more seconds, 28.2, that's when we're going to take the picture, right? So there's our interpretation of d of 10, okay? There's d of 10. Okay? Write the instruction that represents the time in seconds from the moment to the moment the shutter closed. To the moment the shutter closed. All right. So if it's a time in seconds from the street light, what in general will be our form of this? How do we d of something, right? And so now we need, at what time did the shutter close? No, we know. We can figure out that number. Yeah.
Since this was representing the time and not the distance, should we not have the d of?
No. Oh, am I sorry? Yeah, right. I read too fast. We're representing the time in seconds. So it's not d of, right? My fault. It's not the d of. It's just what we would put in the parentheses. So we want an expression that is that time in seconds. Yes, sir.
Just 38.2 plus 1/40.
He wants 38.2 plus 1/40 seconds. Is he right? 38.2 was the time it took for till the shutter opened, right? And if the shutter was open for 1/40 a second, then to close would be 1/40. This is right. That's it. So just because it's an expression doesn't mean it has to have a variable in it, okay? Even if you calculated that number, even if you got that number, anyone get that number? 225? That'd be okay too. But an expression doesn't have to have a variable in it, okay? In this case, we know what the value of the expression is. Questions on that one? Okay, write two expressions. One that represents the SUV's number of feet from the streetlight at the moment the shutter opened. So that's a distance, right? At what time? 38.2. A second that represents the SUV's number of feet from the streetlight at the moment the shutter closed. D of, we want that time from the previous thing, right? There's those answers. So that's the distance from the streetlight when the shutter opened, the distance from the streetlight when the shutter closed. Now an expression that represents the number of feet the SUV traveled while the shutter was open. So how can we get the number of feet it traveled while the shutter was open? Yes, sir?
I had a question for Steve.
Oh, sure.
Because it was stated back at the top of the problem that x was represented in 8.2. Are we allowed to use x for that instead?
No, so x is a variable that can take on any amount of time since the...
But it's in the top of the problem, we represent that x becomes an 8.2.
For this SUV, at the moment, so this is one value. So x takes on many values.
So it's still going to be multiple values no matter what then?
Yeah, so the value of x at the moment the shutter was open is 38.2. But still, so d of x, right? X represents x seconds after passing the streetlight. So x takes on all these different times. So I'm giving you an example of one particular value of x for this SUV. One particular value of x was 38.2 at the moment the shutter was open. So, but x still takes on all the values after it passes values of time after it passed the street light. Okay, so we wrote those two expressions. All right, so what about the distance the truck traveled while the shutter was open? Yeah, Ryan.
The final distance minus the initial distance.
So tell me the whole expression.
So the d of 38.2 plus 1/40
Right?
minus d of 38.2.
What do you think? And what does that have to do with number 1? The distance of the blur on the photo?
How far he traveled.
Yeah, so it was exactly what we were after in number 1, right? This is a representation now using that function of that distance that the truck went, which we were trying to estimate using the photo, right? Is that the last question? Is there one more? Okay, so then it says write an expression that whose value approximates the speed in feet per second while the shutter was open. So we got the distance while the shutter was open. What do we want to do? So this is the change in distance. So what do we do? So change in speed is change in distance. Times change in time? Divided by change in time. So what's our change in time? Or which is the same, did she say times 40? Yeah, sorry, that's right also. Which is like our bar diagram, we need that little distance, we need 40 of those, right? We need 40 of those to get the distance that traveled in 1 second, which would just be the same thing as multiplying that thing by 40. So either way. Okay, is that the last question? Questions on the SUV problem? Okay, cool. So let's move on. We're going to start digging into graphing calculator. So get your laptop open and get graphing calculator going. And when you open up the program, you should get something like this. Okay, so this is called a command line. Does everyone who's got it? And then, can everyone? No, you need this. Yes, absolutely. That's why it's on the announcements. It's on the announcements. Okay, so let's see. Can everyone see a screen? If you can't see a screen, make a friend. If you can't see a screen, find a friend. Okay? All right, so here we go. So these are the command lines. So the first thing I want to show you is that graphing calculator works as a very efficient way to compute values of things. Okay, so notice 5 plus 4. I don't even have to hit equals, and it gives me the current value of this expression equals as a smaller font. Okay. So then so I can divide by. If you type in pi, it just changes it to pi. Okay. If you want to square or cube something, you don't need the caret. All you have to do is do shift. So you can highlight, do shift 2 or shift 3. That's a built-in function that automatically squares or cubes. If you want a different exponent, you need the caret. So that's shift 6. So shift, if you do shift 6, it just digs that, and there you go. And so now I've got this value of 5 plus 5.
Wait, how do you raise it to exponents?
So 2 or 3, all you have to do is shift 2 or shift 3.
Oh,
It'll do it. But any other exponent, you need the caret, but it won't print a caret. It'll just take you to an exponent by saying shift 6. So maybe I should use a different value here. So, okay. Good so far. So here's one great advantage to this over a handheld is, say I can copy and paste these expressions. So copy that, and now with it still highlighted, all you have to do is hit, say, left parenthesis, and it'll put parentheses around. So whenever you put left parenthesis, it'll give you both set. It'll give you the whole set. You never have to put a right parenthesis. Hit left parenthesis on your keyboard.
Oh, okay.
Okay, and now highlight the whole thing and hit divided by, and say we want, so square root on a Mac is option V, and so for you who are savvy with PCs and figure out things out fast, I'm going to have you help me. Does anyone find, is it Control V or something else? Anyone? Alt Command V?
Oh,
No, PC. Anyone figure out square root on a PC?
What is it for you?
Someone got it?
Control Shift R.
Control Shift R on a PC to get square root.
Control Shift R.
Option V. Option V for square root. All right, so say it, but I've got that numerator copied in my clipboard, so I can say like 23 plus, and I can do paste. Questions? Just fire the questions out.
So how do you make it?
PI. PI.
So how do you make the, what's it called?
Highlight it and hit left parenthesis. Oh no, sorry. Highlight it and hit divide, and it'll give you the bar. So just highlight what you want to be the numerator and hit the slash, the divide, and boom, you'll get the fraction.
How do you do the square root?
Okay, on Mac. No, so you're on PC.
Yes.
Tell me again.
Control Shift R.
Control Shift R. Mac, it's option V. So now here's the beauty of this. We've got this expression. Oh, that shouldn't have been. What's an integral? What's that? Okay. 23. So, okay, this is a mistake. I really meant 21.6, and then it just changes the answer on the fly. No, you don't never have to equal or anything. So you can just go in there, mess with a number, and it'll just give you the current value of the expression. Yeah?
How long does this calculator last? Like other computers?
So this is a temporary license, like somewhere in the middle of the semester. It's like in early November or October, it's going to expire, but then I'll give you your own individual code.
So it's just for this year?
I don't know how long that individual code lasts. But, yeah.
Which is the first.
But then it's like, for students, it's like $30.
$30.
$30, but you're getting it free in here. And hopefully, I can email my old students and find out if they still use it or not, if they still have it. Any questions about basic expressions like this? Okay, so let's just do a little exercise here. I want you to write one expression that calculates see how my circles are going today. Oh, not bad. Okay, so say this is 23.6, and this is 18.1, and my height is 5.92, and I want you to find in one expression that finds the area of the red shaded region. Can you make one expression that finds the area of the red shaded region? Given these dimensions. Go, see if you can do it.
What is the 18.1 is the length of the whole chunk?
No, it's the top. So it's the top face.
Oh my God, does that work? I'm in love with this guy.
Does that make sense now? One expression. So, oh, I'm sorry. Sorry. To start a new command line, very important. New command line. It's command return on Mac. That gives you a new command line. Okay? And is it control return on the PC? Control enter on a PC. Command enter on the Mac starts a new command line. So on a new command line, write one expression that will give the area of the red shaded region. Okay, take a minute to do that. Go. I can come around and troubleshoot. Because this is, you do 20 times more and 100 times better. It's because of what we're going to be learning in this course. It's supported by this. So this is just, if you can learn to use this and appreciate it, you will never want to use it.
Yeah, I understand why it's.
You're getting free. You're getting free. You're used to it. Change is good, but it's hard, right?
So I mean, it's not like a sport.
That's what I was fishing.
Oh, it's
That's the diameter you should actually too.
Unless we have to.
I got the
Unless you. Just do numbers fast. Okay, just. You don't have to look at this now. Work on your task at hand. I'll explain this in a second. Oh yeah, so. So if you forgot, what is it? 1/2?
Some of the bases.
Right. There you go. If you forgot.
I don't want to see.
It's the highest by
What are we getting for an answer? You can check. What's the answer? 95.906. That's what you're shooting for. 95.906.
We're trying to figure out
Okay, any questions on that? You want me to set it up? So what's the general structure of the solution? General structure of the solution? So we're going to do the area of the trapezoid 0.5 times 18.1 plus 23.6 times 5.92. And what's that? So currently we're showing area of the trapezoid, right? And now we want to do what? Minus. Okay, parentheses, good.
5.92.
So did anyone go to your handheld calculator and figure out what the radius was?
2.96.
No, I'm asking if you did that. Don't do that, right? Just let it do it for you. 5.92 divided by 2. Right? So this does everything your handheld does, 20 times better, and it does 100 times more than what your calculator can do. Okay, so we want, what do we want? That's the radius. We want to do with what? Square it, so shift 2, and then times pi. 95.9066.
This whole thing is just 35.
What's that?
This whole thing is just 35.
Yeah, wait till you see what it can do. I mean, this is nothing compared to what it can do.
Yeah,
All right. Go. So I don't know if you played the demo, but you start getting into three-dimensional renderings of things, and it's just, it can do so much. Okay. If you can hold on to it till Calc 3, it'll help you with Calc 3 visualizing all this three-dimensional stuff. Questions about the trapezoid problem? Okay, let's move to the handout. Just stay on the first page, where it says engage with the mathematics. So there's nothing on this first page, there's not too much new, but I just want you to practice using it. So we're going to, this is calculating the payment. Okay, questions? Sorry. Everyone got the handout? Who else doesn't have it? Right. Everyone else got the handout? Okay, so basically we're, just like the trapezoid area formula, you're going to start a new line and you're going to put this formula in, not the formula, sorry, not putting the formula in. You're putting calculations in, just like this, that will calculate the monthly payment. So in the middle of the page there, you can see it's calculated for the first row in the table, where the interest rate is 0.06, the principal is 250,000, and the number of payments is 180. And so following the formula, you do 0.06. Everyone do this? 0.06 divided by 12.
Oh, wait, you want to say that?
Yeah, so this is going to be, well, just demonstrating for the first row of the table. So for an interest rate of 6% and a principal loan amount of 250,000, then times. So if asterisk will be a multiplication. So we got 1 divided by 1 minus, parentheses, 1 plus, 0.06 over 12. And then raise 2, shift 6, negative 180, and there we should get our payment, which matches that, the one that's filled in on the table. Yes, sir?
So shift 6 just puts it up there. And then
That's right.
you divide any number.
Right, but if you want to square or cube, you don't need to do that. You just do shift 2, or shift 3 is built in as square or cube. So I want you to, for the page 1, you're using this
Wait, how did you
approach. How did I get right?
the negative 180 exponent?
Shift 6 will start an exponent, like you're going to do a caret, but then there's no caret. Did it work? Okay, so use this approach to finish that table at the bottom of page 1, and don't go on to page 2. So we're just practicing using this thing as a brute force calculator with values. Finish the table. Find the payment amounts for those with this same approach. With this same approach.
Always a negative.
Yeah, the formula up above. Minus the number of payments. That's the number of payments. The formula calls for negative exponent. Okay, I'll make one trip for troubleshooting. Catch me as I go by. If you got a question. Yeah.
Why do you get in negatives? I'm curious.
Oh, that's a whole different story for a whole different day. Okay, that's just what the formula is.
No, actually, you just
You're finishing the table. Word? Yeah, so you're going to finish that table.
oh.
Okay, so just following
That's you have an operation.
Try closing it. So you got something close now. Try closing it.
Well, no, I had actually. Because I had actually just like I changed the plus and I just put
What did you
2997.
Decimal point? Yeah. So, we're gonna have to try one more time. If it's still not working, you have to contact the company. Maybe the website. Yeah. Something's wrong. So the other thing, it's like before you contact them, uninstall it from your computer, go through the whole process of installing it again.
One plus that interest rate.
One plus.
This is not that hard. And this one's
Questions?
And then arrow.
two.
Alright, so which one's that?
This guy's so right.
The last one or the second to last one? I'm going to do that second to last one. So, $2 billion loan, 120 payments. Yeah, I'm about to do that. Okay, so some people have this question, what is it telling you right there? So it's scientific notation. It's telling you, when you see the E and the plus 0.07, it's saying take this number and multiply it by 10 to the 7th, which is the same thing as doing what? Yeah, move the decimal place 7 times, or multiply it by 10 7 times. So we get 1,871. There's 3. 1, 2, 3. Oh, so the commas are in the wrong place. Just do it here. 790. Is that right? 1, 2, 3, 4, 5, 6. Do I need one more? 7. Now we can do the commas. So our payment on this $2 billion loan, our monthly payment is $18 million. It's not ridiculous because our country has a loan of $17 trillion. Yeah, no, the payments are coming, trust me. Enjoy your quality of life now. Okay? All right, so how about this way of calculating these values? Efficient or not?
Yes.
Well, kind of. But we can do a lot better. So let's flip over to page 2. So what we can do is we can use what's called parameters, and we can make formulas with parameters. Okay? So, and that means using variables or letters. But before we can do that, we need to know that this software reserves certain letters for certain things. Okay, so everyone, so look in that box. So X and Y are reserved for the X and Y axis for graphing. Okay, so normally if you start putting X and Y into your formulas, you're commanding it to graph. Okay, so just as placeholders of values, we don't want to use the symbols X and Y. Z is the Z axis. That's talking about some of 3-dimensionals. R is reserved for the radius and polar coordinates. Theta and phi are reserved. Okay, T is reserved for a parametric variable. So are U and V. E is its value, the natural base. pi and I are its value, and n, lowercase n, will pull up what's called a slider. We'll talk about that later. So any capital value, any capital letter is not reserved for something, so we can use it. Okay. So if you just type capital R, notice what happened. Right now it says it's equal to 1. So that's the default. That's the default for an unused parameter. If it's unused, it just has the value of 1. Okay? So what do we want R to be? So let's do the first row of the table together. What do we want R to be in the first row of the table? 0.055. Okay? And then new command line, capital P. Again, not assigned yet. P equals, what's in the first row? 280. Okay, and then capital N. These are all unused parameters. So here is a loan scenario. The rate is 5.5%. The principal amount is $280,000, and we're going to do 360 payments. Okay. So now you can create your own parameters out of a string. So, but we have to do it especially. So if I do PMT. If you do a string of letters like that, it's not a parameter. What are you telling it to do right there? What are you telling?
Multiply.
Yeah, so right now the way we have it is we're actually multiplying 3 values together. So if we want PMT to mean a parameter or a single value, what you do is you hit a backslash, which is above your return, so a true backslash, and then capital PMT, and then backslash again. Now that string of characters is a 1 constant value. Yeah.
Sorry, when you put the backslash, did you press enter right now? Or is it just
No, as soon as you put that second backslash, it just does it automatically.
How do you do that again?
Backslash, PMT, backslash. Not forward, not the normal slash. The backslash is above the return. And that's shown there in the middle of page 2. That's shown there in the middle of page 2. Okay, so we want to create a formula out of our P, R, and N. So we can go equals R over 12. So this is the formula in the middle of the page. Times P times 1 over 1 minus 1 plus R over 12. And then just that raised to the minus capital N. So shift 6 minus capital N. Did I lose you? So here we're setting the values of these parameters, and then we're defining this parameter PMT as the value of this formula. Everyone good? So now if you make one more new command line, and you type in PMT, new command line, type capital PMT, now it's calculating the formula for the current values of P, R, and N.
When you do the backslash, PMT, backslash, what are you hitting in order to set? Are you hitting enter? Because I'm not.
Your N is supposed to be 120.
I was doing the first row. Yeah, thank you. So for the first row, it should be 120. But look what happens. So here, watch. So currently N is 360. I'm going to change N to 120, and automatically that payment updates. The formula updates there. See that? Yeah.
I didn't see how you were able to set the value on the other side of the
Equals. Just type equals. Just type what it says. Yeah, equals. Okay, we still have a little left to do, so just stay with me. So this is a lot more efficient. So if you want the second row of the table, or let's do our big loan again. What's the interest rate in the big loan? 2.35%. So just go back to the R value and go 0.0235. And then the principal amount was our what? 2 billion. 1, 2, 3, 1, 2, 3, 1, 2, 3. Number of payments still 120. So there's that's the same value we calculated before. Yeah.
Sorry. To like just highlight them, you're just using your cursor and just tapping on it, right? Like.
On what? I just went back to these lines and just changed it, just like you would in a word processor.
Okay.
You can backspace, you can highlight and delete, just like a word processor.
Okay.
Just go back to these lines, change those values, and this will always then give you the current value of payment for whatever your P, R, and N are. So just do one more row of that. We got something else to do. Just do any row you want in that table on the back of page 2. Or let's all do the same one so we get the same thing. Let's do row 2. Everyone do row 2 of that second table using this approach. Using this approach now. Yeah.
Yes.
You say it has an equal sign. You mean equal sign.
Oh.
You have to type the equal sign when you're setting the value of the parameter. You have to type the equal sign.
Okay.
Yes.
We're just gonna sing the whole class together.
There. U5 here. Okay, what are we getting for the second row? Second row?
$3,295.06.
We got 33.95.65, and what you got? Anybody else get 33.95.65? Okay, that seems like that's what it is.
We'll do this.
Okay, now so one of the really nice things about this calculator is we have an even more efficient way of doing the same thing. Yeah, that one, that's one. Does everyone have page 2 or the second sheet? No. Like, you guys get the second sheet? Does everyone have the second sheet? Okay, so we can do this even more efficiently, and we can set up functions, what we just learned about in this class, right? We just learned about functions are deterministic relationships, and they're very useful for what? Repeating a process over and over again, just like what we're doing. So to set up a function, I'm going to set up a new window here. No, I'm not. No, leave them. Don't change them. So now here's how we do a function. So start a new command line. So f is our name of the function. Now, if you put just parentheses, it's kind of like you're telling it to multiply. Sometimes it knows that you want a function, but sometimes it doesn't. So here's how you can always tell it for sure that you want a function. Instead of doing shift 9, you do control 9. You're signaling to it that this is a function and not multiplication. Now sometimes it will figure out that you mean a function and will change it for you, but don't count on that. Just whenever you're using function notation, instead of shift 9, do control 9, and then it will know for sure.
And it must be lowercase f, right?
No, you can name the function anything you want.
What is it for a
Control 9. It's for everyone is control 9. So far we've been talking about functions of, okay, so far we've been talking about functions of with one input. Now this is really a function of 3 different inputs, right? You get 3 inputs, the rate, the principal, and the number of payments, and it spits out the output. So to do that, you just put those as a comma. So go capital R, comma, capital P, comma, capital N. So you're telling it that you're about to give it a rule that's going to involve R, P, and N that's going to crank out an output with those inputs. So we don't have to, all we have to do is highlight that and copy it, and then come down here to the question mark and paste it, and we've just established our function. And if you hit enter or start a new command line, so now we've established our function R, P, and N. So how do we represent, so let's look on that new page. Let's do the first row on the line. How do we represent the payment using our function notation for a rate of 16%, a loan amount of 200,000, and a number of payments of 180? How do we represent that? No. This command line is establishing the function. Now we want a particular output. How do we represent a particular output?
So we're gonna be
F.
Control 9.
Control 9.
Did you say how much the payment is?
First row on the sheet there.
Also,
0.16
1.6, yes.
is P, or is R. P is 200,000. N is
180.
okay. So here's the beauty of this software. The beauty of the software is it interprets and has this forum for functions just like what we've learned. What does this represent? This represents the output of the function for these inputs, and it's telling you what that value is. Where you set the function up here like this. Okay? We haven't even started graphing yet. Okay? We haven't started graphing. But the great thing about the software is it handles functions the same way that we deal with functions. If you have f of something, that represents an output. There's the value of that output. Okay, all you need to do, change whatever you change in here. However you change the first one, it will plug that value into R. However you change the second one, it will plug that value in for P. However you change the third one, it will substitute that value for N to calculate the value of the output. Okay, so what I'm going to have you do for Friday's homework, I will put this on Blackboard, but just so you have an announcement, will be the back page of this new handout called a graphing exercise. And then I'll also post another graphing exercise on Blackboard along with that. So it'll be the back of the sheet along with what I post in the next couple hours. That will be due Friday. Thanks for staying late. I'm going to give you the time back another day.
Yeah.